Okay, this is just a quick video to explain sigma notation. What does it mean and what does it translate to? So the Greek letter capital sigma, as hopefully we have seen in other examples before, particularly statistics, this means the sum of. Sigma x is the sum of all x values. Sigma y is the sum of all y values. And it's a lot simpler to write long sums using sigma rather than anything else. And there's only really three things that we need to worry about in sigma notation. The first one is the bounds. And in order to illustrate this, I'm just going to use a nice simple example, nothing too crazy. 1, 2, 3, 4, 5, 6, 7, 8. Just numbers 1 to 8. Let's say I wanted to write an expression for summing all of the numbers from 1 to 6. Well, the first thing I would need to do is come up with an equation for each term in this sequence in terms of, let's say, n. Now, luckily, this sequence is nice and simple. If n is the nth term in the sequence, well, the second term is 2, the third term is 3, the fourth term is 4. The equation of this sequence is literally just n, which is, lucky in this case. I'll show you a slightly more complicated example in a minute. So, if my nth term is just n, then that is what goes in front of the sigma. If you've seen an integral sign by now, it works in a very similar way. In fact, some could argue they are technically the same function, just one's a little bit more precise. A lot more precise. So we write our nth term in here. This tells us the rules for the sequence we are summing. Then let's say I only want to sum the first to the fifth terms from n equals 1 to n equals 5. Well, this is where I draw in my bounds. So on the bottom, I would write n equals 1, my lower bound. Now, key thing here, I don't just want to write 1, I want to write n equals 1. The reason I want the n equals is because I want to tell myself or anyone reading my work what variable am I increasing. So in this case, there's only one variable, it's n, but if I had an x in here, for example, I want to distinguish between summing n's, summing x's, or summing both. So I tell myself what variable am I summing here, and it is n. And then for the upper bound, I just want to write 5, because that is the number I'm summing up until. I don't need to write n equals up here, just writing it once at the bottom is convention, and it's also more than satisfactory. So this tells me to take my sequence with an nth term of n and sum the numbers from the first term to the fifth term, which in this case, 1 plus 2 plus 3 plus 4 plus 5 would be 15. Okay, let's have a look at a slightly harder example. In this case, I'm taking a sequence that has an nth term 2r plus 3. This time I've got an r instead of an n. You could see either letter, but typically it might actually be r more than n. So, what is this sequence? Well, let's write it out. My first term, r equals 1, 2 times 1 plus 3 is 5. My second term, 2 times 2 plus 3 is 7. My third term, 2 times 3 plus 3 is 9. And I can probably see the pattern. I'm just adding 2 every time. Just some nice simple nth term stuff. And what's this telling me? I am summing the second term up until the fifth. So I'm doing 7 plus 9 plus 11 plus 13, which gives me 16, 27, 40. Nice and simple. Finally, I just want you to get used to weird limits. Limits that aren't starting at 1, basically. Even the last example, starting at 2, we're going to want to implement another method. So, what's often easier than summing between a weird number like 5 and 30 is to transform this and split it apart into 2 constituent parts. Because this is just adding, and in this case it's the most simple example of n that we saw 2 examples ago, because we're just adding the 5th term to the 30th term, this is the same as adding the first term to the 30th term and then minusing the first 5 terms, right? If I wanted to add up 1 plus 2 plus 3 plus 4 plus 5 plus 6 all the way to 30, and then take away 1 plus 2 plus 3 plus 4, I would get the sum from 5 to 30. So I can split up this sum into from n is 1 to 30n minus from n is 1 to 4n. And this is the same as this. And this is something very key that you might want to get used to, because quite often it's much easier to work with the first term in the sequence versus the 5th. So we always want to try and make sure that our first term is on the bottom and nothing weird.